business. Not just code lab. Yeah.
Yeah.
What's our cutoff?
So 45.
That's rude. Do that. Yep.
Okay. Hi everyone. It's my pleasure to introduce Olson and Paul Lundberg from Augusta. They're going to be talking about the highly scalable Internet of Things on Google Cloud Platform.
Thank you. I'm going to start and go through just an overview of what we're all going to narrow from IoT down to kind of what we're working on. And Aaron's going to show a demo here that I'll kind of set up throughout the first part of the talk. So first of all, just quickly about Augusta, in case you don't know who we are. We're a local company here working out of the Ford Center. We host the GDG every other month, so if you can make it to our GDG meetups, I recognize a number of you from the meetups. You can see our place. We've got a growing development team focused in a couple of particular areas. One is around IoT product development, so helping our customers develop products that are IoT related. And then we're also working on our own product. So about half of our dev team is working on a product that we're building called SkyKit. Not related to IoT yet, it will be in the future. And then the other is around IoT-based projects. So we'll get into a little bit more about how we started and how we got going. When somebody says, I'm doing IoT, what does that even mean? And what part of what we're going to do at the beginning of the talk here is just break that down a little bit. We'll tell you where we started. I'm standing right in front of the screen here. I'll just move off here. Sorry about that. So there's all kinds of stuff going on in IoT today in all kinds of verticals, and part of our challenge has been to really figure out where do we want to play. From a technology standpoint, it was kind of easy. We naturally fit into more of back end of IoT. But in terms of verticals, it's been interesting to kind of figure out where we want to play and where our opportunities are going to be. So right now, if you guys know the Gartner hype cycle from this last year, right up on the top there, you have Internet of Things and IoT platforms coming up. So we're kind of at that point where there's lots and lots of buzz about IoT. Everybody wants to understand it. Everybody wants to work on it, but it's going to settle. It'll settle down before it matures. I was at CES this year in Vegas in the IoT area. Spent the whole time in the IoT area, and it was just amazing how many different products and companies were there. Many just showing the same stuff. And it was just, I can't tell you how many wireless-based security platforms that looked at it. You can just see that it's going to have to settle out and mature. Some people, we had a consultant one time tell us the very early days of IoT, and it's very immature, and that's kind of a good thing and a bad thing, the way we view it right now. So there's a lot of buzz right now in Google land about Weave and Brillo, some of the underlying, closer to the device and the lower level protocols. The reality is a lot of this stuff's not really ready today. So when we're talking to customers and they're telling us about their problems and what they want to do, a lot of this stuff is up and coming, and we're watching it closely, and we're interested, but it's not really a reality yet for us. I thought this was kind of good. What's Google up to, in terms of IoT? This is back to what everybody jabs at Google about, right? About the data. They're after the data. They're doing Brillo and Weave so they can get to all the data. So maybe that's true. We'll see. But we are very interested in what Google's doing there. So if we just try to break IoT down a little bit in terms of all the layers and what's going on, and just so I can help you understand where we're playing here. way at the bottom of the stack, you've actually got the devices themselves, and all kinds of devices, and a lot of the devices that we're finding, and a lot of the opportunities that we're working with customers on are related to some sensors and devices that have been out in the field for actually a long time. It's just that in some cases they're reporting data into a computer at the facility or a server at the facility, and it's being looked at and analyzed there, but they've got 500 facilities and the data's not really getting rolled up very well, at least not in real time. Sometimes it's being captured on the local server, they're collecting it all, they're doing kind of all the day-to-day event-based things that they need to do to control the facility, but then the data is really not available to be analyzed or used in any kind of a real-time way. And so a lot of the IoT opportunity right now is how do we take some of the crusty old devices that are out there and how do we bring them into the cloud into a way where we can actually perform analytics and do more advanced event processing and kind of roll this data together and see trending and that kind of thing. So that's the silicon level. And then you get into what's the connectivity look like. Is it Wi-Fi? Is it Internet Connect? Is it a mesh network, Zigbee or Z-Wave or some of those older protocols or more established protocols? And then you get into how are we handling and queuing all those events up, and how are we delivering those to the cloud? So then you finally cross over from the device in our world into the cloud, and then you're going to kind of start in on the processing that goes on with all these events that are coming from all kinds of different places. And so in our world, we've been working a lot up in this area. We'll come back to this picture later. So we got into IoT probably 3 or 4 years, probably 4 years ago now. We worked on a product that was around law enforcement, having to do with image recognition. So we were taking events in, and it was all HTTP based. So it was really pretty straightforward for us. It's like, we put up an HTTP endpoint, we take in the data, and these devices were powered, and there didn't seem to be a network data problem. So it was pretty simple or straightforward for us to start to work with that and do event processing. So that was our first project, and then we got into the next project, which was, and that's still very active, which is around a commercial fleet management IoT system. And when we got into the project, when we were introduced to this customer, they'd already gone down the path of building out the device with a partner, with a third party, and they again had based it off HTTP. The events that were coming from commercial vehicles were only coming about every 5 minutes, so it didn't need to be kind of constant connection and streaming of data. And they decided on HTTP. I don't know why. We didn't get too much into that. We helped them define what the payloads were that were going to be part of that. But the decision was already made, and what we saw in that project is eventually they started to see that they were having some data usage issues. Even as it started to scale, the even event packets coming every 5 minutes was starting to go over what they were projecting around their data plans, and they were looking at how could we reduce our costs around these mobile data plans that we have to have. So that was interesting. And then the next project we got involved with is around industrial lighting, and that's the one we're going to focus a little bit more on today in terms of the use case. Really interesting because they had wireless. They have much more data streaming potentially, and wanted to have a lower level protocol that was more data efficient, and also wanted to be able to have more of a real-time kind of connectivity. So we started to get into that problem. That's a lot of what we've been expanding on in our experience has been around kind of the device to cloud connectivity, which is kind of the basis for our discussion. So this is our IoT accelerator architecture that is kind of the blueprint for what we use when we're starting with a customer. And we kind of start right here when we start to receive the events from the devices, and then all this stuff that's kind of typical in terms of what you do once you're receiving the events in terms of processing the events and doing notifications and being able to send messaging back to the devices, and basically just keeping track of all the data and eventually getting to the analytics. That was kind of what we're really comfortable with. That's our happy place, and this is really kind of what we've been doing for a long time and have had a pretty good command of. So with this project I'm kind of telling you about now, we're getting into where they're saying, hey, you got to help us figure out how to get this data from this device gateway into the cloud. And we're like, well, it's not HTTP. It wasn't something that we were really comfortable with. Just as a background, I just want to do a little bit on cloud platform. So that whole picture I showed you is really all built on Google's cloud platform, and these are really the major components of cloud platform. Although you could make a huge list of other APIs, and it's kind of a high-level view of Google's cloud platform. So the way we've done development at Augusta is really to focus on platform as a service as our go-to. So meaning that if we can, we want to develop this on App Engine in terms of our event processing, so we get auto-scaling, and so that we're not developing and standing up our own infrastructure. So some people, how many people are familiar with App Engine, or what that's about, how it's different from? Yeah, so you better be. So App Engine really, the idea is that the best way to describe it is we build our application, we zip it up or archive it, and we hand it over to Google, and we give it some directives about how we want that application to run and how to scale. And so we don't install virtual servers and do a lot of the stuff actually we're going to talk about now, because the things we're going to talk about today we can't do in App Engine. So that's our go-to, is to try to do everything we can, platform as a service, where we're using App Engine, and let's just say that we need an object storage facility to put images and video and that sort of thing. We'd use a service from Google called Cloud Storage, which is an API-driven service. We don't have to worry about scaling it. We don't have to worry about running out of space. We don't have to worry about, all we have to do is pay for what we're using. So our only worry is if we aren't managing our usage very well, it can continue to grow. But outside of that, we're never going to just run out of space or have to set up another server or any of that. Same with Cloud Data Store being our backend for database, or if we want to use SQL for a backend. All this is highly scalable, given to us as a service to use and priced. All these individual components are priced by usage, huge breakdown of how you get charged for these services. So lots of other things here. The next picture are more of the ones that we tends to be pretty typical in a project that we would take on. And Compute Engine is really infrastructure as a service, so that's where we're dealing with building up a virtual server, and Google's pretty good at helping us to scale that kind of infrastructure now. That's come a long way, but we're still managing our own images of servers and things like that. So all these other things are really offered as a service, and tends to be how we typically build our applications. I talked about this a little bit in terms of some of the challenges and why we're getting into talking about this device to cloud topic. Device to cloud, the bandwidth issues around how much data are you using. Many of these devices are going to be connected, are going to be connected by a mobile network, and so you have to be very conscious about how much data you're using. There's also often a need to have more of a real-time flow of data, and so that can be an issue too with using something like just straight HTTP. Security is always a huge issue. Every customer we ever talk to, they're just so concerned about the data and how they can guarantee that it's going to be secure from the device all the way to the cloud, and so we kind of look at and work with customers on what's the life cycle of the data. And actually that framework that I showed you that we built up, we call it the event lifecycle framework, because it's really about about what is the life cycle of an event from the time it leaves the sensor to hitting the cloud and until we process it and archive it, and when does it get removed, and does it need to get removed, and all of that. So that gets to be a pretty big topic, and security is always very, very high on the list of issues that we address with customers. And actually, Google is very helpful to us in that regard. We can often point back to Google and Google security white papers, and because everything we have is, for the most part, running in Google's cloud. So that's actually a great help. So the scenario we're talking about today, and that we're actually actively working on it with a project, is lighting, industrial lighting, where we want to have lighting control for the purposes of energy usage and safety. And so we're working on a company that started to build up this product sometime back, and we're now engaged with them working on kind of a second version of this product that's going to kind of rip out some of the original technology and put in some new technology. So basically, you've got some kind of a facility like this, and you've got all these lighting nodes, and on a level, let's say, of a parking ramp, these nodes are all connected through a wireless mesh, low energy, Bluetooth. Actually, this one is Zigbee. It's a Zigbee mesh. So we can, and there's a gateway node on this Zigbee mesh then that's responsible for communicating the messaging or the events to the cloud, if that's where we're shifting the back end to be cloud-based. So the idea would be that, that there's a gateway that's kind of, the mesh gets the data to the gateway moves it to the cloud, and then we can do our processing. So so parking ramps are a great use case for this kind of thing, where you can set up a mesh where each lighting node is a node on that network, and the industrial design partner we're working with has scaled that up to somewhere around 1,000 devices that they can put in a mesh, so there can be one gateway servicing many nodes. So city lighting is another nice use case for this kind of thing, where we're trying to control city lighting, again, for the purposes of energy use and safety. Although I wouldn't recommend turning the lights off on the bridge. And so maybe on street lighting it would look something like that. So again, we have nodes that are kind of connecting with a mesh to the different lighting modules, and we need to have a gateway that can move that data to the cloud. So back to this picture. So trying to just provide some context here, and describing that this is where we've done a lot of work in terms of event ingestion and processing and all of that, and that now we're working. We'll just talk about the specific use case. So we're working with Zigbee in terms of a network protocol. There's a mesh behind it. We have a gateway, and we want to move the data to the cloud in a very efficient way, and also have a way to command back to any of those devices from the cloud. So you saw that slide with a lot of the emerging technologies that are coming around devices and that. So we kind of settled on MQTT as a protocol. It's been around a long time. People that have worked on, what used to be, let's say, machine to machine would probably be familiar with MQTT. It's been around, and it's kind of tried and true, and it's well supported, and library support across many different languages. And there's a few other alternatives that we could have selected that would have been probably okay as well, but we settled on this, and it seems to work really well. It's been around a long time. In terms of a message broker, so here's an example of a component that we can't run this in App Engine. So when we need this message brokering to happen between the device and our cloud application, and we want a message broker. Google has PubSub, which is a good product for message brokering, except that it's all HTTP based. So it doesn't yet support protocols like MQTT or lower level protocols. So we have to put this component in the middle, which someday we hope we wouldn't have to do. Someday we would hope that Google would enhance their service so that we could just connect up with some different protocols and go right to the cloud from the device. But for now, we have to kind of build something in between. So what we're using is pretty standard RabbitMQ. We've developed a adapter that is going to basically translate the MQTT messaging into something that application developers would like to use, which would be either PubSub, and that's kind of what we've selected for this particular application. But maybe they just want to stand up a REST endpoint that's compatible and ingest it through a REST endpoint. So what we're kind of doing with our adapter that we built with RabbitMQ is to we want customers to not have to use, or application developers to use like an MQTT client or something like that. So trying to kind of translate things into more of an application developer's world. So why did we pick Rabbit? I don't know if we have a great answer to this, other than Google had done quite a bit of work on RabbitMQ and proving that they could handle really high message volumes. They had a click to deploy on Compute Engine for RabbitMQ. So that's kind of how we got started down the RabbitMQ path, and didn't really find any reason to do something differently. And it's been working really well. It's a really solid, tried and true. There's lots of good documentation. There's lots of the development community talking about it, and so I'd say it worked out really well. ActiveMQ, maybe you're familiar with that, would be another platform that's been around a long time that could have been used in most of this. So, how are we doing there? Yeah. Okay, so I'll just kind of walk you through the picture then of what I've been talking about. So we've got Bluetooth Low Energy is going to be a newer. There's a technology called CSR Mesh that we're starting to look at and use. This, in the case I was talking about, this would be Zigbee. And so then we have this is the gateway. Then this lives in the parking ramp, let's say, and there's an interface here basically to take the data off the Zigbee network and move it and then use the MQTT client then to move that data on. So there's a Zigbee coordinator component here that really is a library kind of taking the data off the mesh. And then we're moving the data using our MQTT client that runs on this gateway to, this is RabbitMQ running in Compute Engine. And we'll show you some of the components of this when we get into the demo part of this. So RabbitMQ being the message broker, this PubSub adapter being the piece that we wrote to translate the MQTT messaging into PubSub messaging. And then once we cross this, well, we're in Google's infrastructure here. Here we're in Compute Engine, which means we're infrastructure as a service, kind of the things that we built up to accomplish this message routing. And then we get into more of where we're using the PubSub service and our App Engine-based application to do all our event processing and everything we talked about in terms of what we do with backend.
On your architecture picture, you showed message routing and queuing below the device line, below the server line. It seems like it's kind of up in the server.
Yeah, let me see.
Queuing collection.
Here?
Yeah.
So, so oftentimes what happens is you're doing, well, let's see.
Yeah, you're queuing, and the server is sitting up there with analytics. The queuing here with RabbitMQ or Flume, Kafka, or whatever you want, is taking the messages from, it's basically doing load balancing.
So
and
even though
stacking.
that's in the cloud, you kind of view it as device level stuff.
Well, I suppose that we could have a component, depending on how we're connected to the cloud, this RabbitMQ could run on a gateway, for example, and we message, we could be putting messages together and handling some queuing at that level. In terms of what we're doing, our RabbitMQ is running in the cloud, and our individual gateways are communicating using MQTT to the cloud. So we have all the gateways communicating to a single RabbitMQ cluster, where we could have each gateway, many gateways running some kind of a messaging stack here, but that's not how we can implement it. But yeah, that's a good point with this particular diagram I pulled out. Any other questions on so far where we're at? Okay. So just very quickly, just to give you a picture of this little proxy that we wrote is, so what we're really doing is that these MQTT topics are really in a particular kind of format, and really the way, I guess the quickest way to explain it is that an MQTT topic gets down all the way to an individual device. And when we're setting up our PubSub topics, which is in Google's cloud using PubSub, we're mapping many devices to more of a particular topic, like if we're doing temperature or something. Temperature, maybe pressure is a different topic, so that we're publishing to a queue in PubSub, and the application then is subscribed to that and coming and pulling those messages up. So some parts of the application care about temperature, another part of the application cares about pressure, another one wants to look at both of them, or the log wants all of them, that sort of thing. So we have, really what we're doing here is just a little bit of a mapping from our MQTT topics to PubSub. And again, we have many gateways all kind of converging into this MQTT RabbitMQ, and then converting into PubSub topics. And at that point now, when we're PubSub, now a subscriber of the PubSub queues is using, it's HTTP based, it's very API-like, and we're in a place where application developers are very comfortable working with that. So this view is how we've kind of set up our test, or how we do development around this, where we don't actually have a whole bunch of gateways yet that we're working with, and we need to simulate gateways. And we want to do things early on, like test the throughput and load, and make sure that we want to measure data usage. So if these gateways are going to be connected through a mobile network, we have a pretty good idea what our payload size looks like for the messaging that's going to be coming from various gateways. And we want to understand throughput, we want to measure data, understand, so that as our customers building up their model for their product, they can see and understand what the costs are going to be. What am I going to need for a mobile data plan to support the messaging that we want to do for this solution? And what's our throughput? How far can we go with X number of nodes in this instance before we have to go higher? And maybe they want to test, oftentimes want to test scalability for, we project in 3, 4, 5 years that our product, if it's successful, is going to grow in this way. So we want to make sure and test through simulation that we're going to be able to support that with this architecture. So those are the kind of things we tend to get involved with kind of early on with a customer. So what we've set up in Cloud Platform in Compute Engine is this environment that will show you where in Compute Engine there's a concept called instance groups. So we've got a load tester which represents a bunch of gateways, as you described in our picture. So each one of these is set up with 100 gateways. So we fire up a virtual machine, it's got 100 gateways that are all running, simulating gateways, sending that payload that we've kind of understood from our customer in terms of what those typical messaging payloads are going to look like. And we bring, so that the instance group lets us define how many of these instances you want. We point to the virtual machine that we built up to be our load tester, and we can set things like where it's going to run, and do we want to turn on auto scaling and that sort of thing. So that's so this template ends up looking like this when we're running it, where we've told it how many of these we want. We've told it how many gateways we're simulating, and that's all built right into that virtual that image that we have defined or associated with this instance group. And similarly, on the other side, then we've got an instance group for these different types of nodes that we have in RabbitMQ. There's a stat node that's really just there to make sure everything's getting saved and to disk, and we have RAM nodes which run just memory based, and you have kind of a combination of these types of nodes in a RabbitMQ infrastructure. And then we have in this template for the virtual machine, we've got our adapter, our pub sub adapter that we built into that. And so we kind of get our RabbitMQ whole instance fired up based on these instance group templates, and then we fire up our simulator and get that all running, and then we start to see the load coming through we see the gateway simulator running and putting load on the RabbitMQ, and we see messaging. What's not on the picture here is pub sub. So this previous picture just kind of took us through here, and now we're talking about pub sub as well. So RabbitMQ is going to then interface with those pub sub topics, and now again we're to a place where we're ready for application developers to be subscribing to those pub sub topics and taking the data and doing what they do with that event life cycle. So so the demo that we've kind of put together is we'll be able to see, and Aaron will walk through this and show the compute engine console, where we can kind of see, we can go look at the instance group and how that's defined. We can see that those are up and running. The load balancers is something that just gets configured as part of compute engine. And then the RabbitMQ console gives us a view of this whole infrastructure that we've set up. We can also use compute engine to see all these virtual machines that we've set up and have running. But then the RabbitMQ console gives us a view of all the messaging and what's really happening with RabbitMQ. And then in the cloud, we have cloud monitoring, which is based off Stackdriver, that shows us our pub sub dashboard, so we can see what's going on with the queues. So we can see that messaging is flowing through and hitting the queues. And right now, we don't have anybody subscribed to the queues, so that it kind of comes in and just falls off. Any questions on that? Otherwise, I think we're ready to kind of jump into Aaron, show us around a little bit in terms of the demo. See if I had anything else. Oh, and then there's another little IoT humor I kind of like. Where could kind of get out of hand in the consumer side of things. So any questions or anything you guys want to discuss before we get into the demo? I think we're okay for time. So, question?
Yeah, how are you handling, or do you have to handle points of failure, or like if they stop talking, or at the various levels and everything?
Yeah, that's
You talk about it from like an analytics side, so it's not controlling the devices, so it's not like the lights are going to shut off in the garage like the connection problem.
That's true. Yeah. So So in this case, they call it a manifest that basically just has, think of it as the database that's kind of being synced with the cloud in terms of what is that parking facility supposed to be doing, So if we lose internet connection or something happens in the back end, it's really not gonna affect they're gonna continue to operate on the schedule that they have. So the schedule would tell them what to do indefinitely. So we can, survive any kind of a network outage or something like that from that perspective. In terms of the, like let's say the message routing and that, that's set up in kind of a scalable architecture where those nodes are kind of set to be a certain number of nodes. So if one goes down, another one would start back up again. And that's where the instance groups, if you go into an instance group and it says I've got 3 virtual machines running. If I change it to 4, it'll bring up another one. If I change it to 2, it'll kill a couple nodes. So all of that's kind of built in that way, where we have redundancy. And the RabbitMQ has resiliency too in terms of how that's built with its stats node, just kind of making sure we've got everything. If we have to restart that RabbitMQ cluster, we're not going to lose any messages, and the RAM node's kind of handling the load so that we can auto scale that if we need to have more nodes to handle the message load. That'll just auto scale. Once we get over into PubSub and kind of the application stack, we're relying on Google to make sure that these services are resilient. So PubSub, and the beauty is that we're now kind of out of that infrastructure game. Much like a lot of what we're talking about today, and we're using RabbitMQ, which is providing us a lot. We don't have to build a lot, but we're starting to depend on Google now to make sure that we've got really hardened, resilient services. To where there's things going down, but we're not aware of it. We don't have to care. So, does that answer your question? Okay.
So on the message protocol, is that like at least once, at most once? The different.
Oh, for the queuing?
Yeah. At most once, or at least once, or exactly once?
Yeah. Well, I know we want to only process it once, so it has to be. I know what you're talking about, the RabbitMQ policy that you can set up in that. So, Ray, do you have any better answers to that? I can't remember exactly what our configuration was for that, but there's a lot of flexibility there in terms of how you can set up RabbitMQ and the type of queuing that you want to do. But we want to absolutely make sure that we don't ever miss a message. So, whatever that configuration is, that's what we do.
Yeah, and to add on to that, the way the current gateway works is there's actually a confirmation that goes back to it, so messages sent.
Automatically retried.
Yeah.
It gets an acknowledge.
There's an acknowledge message that actually goes back to the gateway. It doesn't get that acknowledgement then. It should be sent to someone.
Other questions? All right, let's switch over to, so there's your Compute Engine Rabbit and PubSub. So this is the Compute Engine dashboard inside of Google Console. This is where you set up virtual machines. There's other things you can do in here if you're familiar with this platform at all. You can make app engine instances or set up databases or whatever you need to do. So we have these RabbitMQ clusters. That's what I want to talk about. And there's 2 virtual machine groups that we have handling that. There's the RAM nodes, which are taking in the messaging that's handling the ingress data. And then the stats node, which is pulling the configuration for these VMs. It's really what's allowing it to be available. If RAM nodes go up and down, the stats node or disk node is holding everything together. So you can have a couple disk nodes if you needed to, if you were concerned with high availability. But other than that, you just want as many RAM nodes as you can get to take as much data in as possible. And
configs for those are set up inside of instance groups. So we have one group for RAM nodes and another group for, there should be another group for stats node.
You know, I guess.
Yeah, I showed that as an instance group, but right now we only have stats node.
That's fine.
We just have a
Yeah, you don't need a group for it. Yeah. So if I go into this group, you can see right now we have 2 of them running. You can see they're not sweating very hard. If I was to edit the group, I could add more nodes to this group if I wanted to manually build out more of these. If I thought that the CPU usage was running really hot or something, you could increase that. Templates, where we actually set up the configurations for these virtual machines. So if I go with the RAM nodes, see it's it's the machine type. This is a pre-configured VM that Google provides you for high throughput. It's a pretty strong machine, powerful machine. It's got standard disk, 10 gigabytes. We have some custom metadata down here that determines what happens when the machine starts up, and in here is where we go and get our proxy image, set that up. So each of these RAM nodes is running an instance of our proxy on it, along with the regular, like the Ubuntu image or some kind of Linux distro on these images. So
I was kind of just, when it says proxy, that's why I was calling it pub sub adapter, where we're kind of doing that translate. That's a little component we wrote.
Yep.
So.
Pub sub adapter. So these stats nodes, or these RAM nodes, excuse me, the RAM nodes can take the MQTT messages and process them via the adapter, and then push them back up to Google's pub sub, where they can get to a database or. So let's see. Go up to RabbitMQ. So we have RabbitMQ running here. We can see. Here's our 2 RAM nodes and our disk node. There's not a whole lot going on here. We have, looks like we have 1 thing hitting these right now for 4 messages a second, which isn't very much. But this is where you would watch your traffic for these RabbitMQ. If you think this is your queue, if you, looks like as they're coming in, we're not even seeing anything get to the queue because they're being processed before they can go. So if I go back to compute engineering and go to my instance groups, go to our load tester. These load testers are another VM that we made where they're simulating gateways. And each of these load tester VMs is simulating 100 gateways, and each gateway is pushing 4 messages a second. So each VM is doing 400 messages a second. So if I just did 10, that's 4,000 messages a second. And they'll take a little bit to start up.
One thing that's, if you just think about what we're doing here in these load tests, where we're wanting to scale things way up and then shut it back down, and this is really the power. I think about how we used to do things 10 years ago. Like, to do this test, I'm going to set up 10 machines, and I want to, we've got all these nodes running, and we basically set it up and we pay for it for a half hour, run our test, go, what did we learn, shut it all back down, go kind of figure out what our next step's going to be, and do it again. It's really pretty amazing when you look at how low the cost is to be able to do this kind of testing and simulate this kind of thing for our customer who's trying to understand, when our product's successful and we get up to this many messages, is it going to work, and what's it going to cost, and we can turn it on for an hour, run that traffic through, see what Google charges for that, do some projections. It's all pretty amazing. So, and really, in terms of how you do this kind of work, it's really hard to estimate individual computing components. The best thing to do is you take as close as you can get to the data that's going to be used, and as close as you get to the number of gateways, simulations are really the most effective way to come up with good cost estimates, because if you ever looked at a Google bill, like for all the components that we're using here, it's endless. And there's a lot of things that are 3 cents and 1 cent and 2 cents, and here's one that's $5 and here. And so a lot of times our customers think that we could just go, well, can't you just plug all this into a calculator and kind of see what it's going to cost? And the reality is there's so many elements of computing that you're getting charged for. Very few of them are drivers for what your actual cost is going to be. And the only way that we feel really comfortable giving a customer a number to put in their model, into their business model, is to actually just set it up and run it. And the fact that we can actually do that is pretty awesome.
The VMs are starting up now. You can see it's starting to get some traffic here. It's taking in, it's publishing about 500 bucks a second. Delivering double that, because to deliver them, it takes them out. It's always like roughly twice. The VMs still not too taxed at all.
What's the size and contents of like an average message?
Our messages, I believe they're like about a megabyte.
No,
No,
they're
no.
really small.
They're smaller than that?
They're, like just for this test, we've got, I don't know, 30 bytes or something like that, 50
They're really
bytes.
small.
And where you're thinking about it, like a gateway might send some occupancy sensor data, right? Somebody walks into a facility and it detects that, and if you want to get that back, it's bytes. Because they really want to, because these are on mobile networks, you want things to be big. So they could be big, they could be megabytes, but in this case, they're not.
Sometimes depending on the device, at the device level, they're accumulating all the messaging. So they're like something that's got a lot of different sensors on it. They're kind of taking all the sensor data in, and they're arriving at some summary data, and that's what they want to push up to the cloud. So that's where each customer situation, the kind of the payloads and that are different. And what we're trying to do is look at their spec, ask questions about how many of these kinds of events or messages they're going to have, how many of those, and how many gateways, and then we can kind of do our projections and put together a simulation that we think pretty closely represents reality. I think we're going to try to wrap with you. Oh, you want to
Show
show
the
the
post
post-up?
I can show the post-up graph here.
Drag.
I know, I like that.
Bring it, the little thing.
So much like we had the MQTT, where you can see the RabbitMQ
Alright.
topics, now we're looking at our PubSub topics. So what we see is in a system that we developed, we see that there be many MQTT topics and less PubSub topics, and then we just be able to see kind of what's going on with the PubSub queues and how they're building and that kind of thing. Here we're not really worrying as much about scale, because Google's going to scale that for us. It's different than RabbitMQ. And so at this point, we're kind of taking it from the device all the way, it's sitting in PubSub, it's ready to go, ready for the application, people developing apps to do event processing, to subscribe to those PubSub topics, and then kind of start on with the second half of the show, which is kind of just all the event processing that was going on in the back end. So
Can you give any insights into the analytics that are running on top? Things we're looking for there?
You mean in the back, more in the back
Like
end
in
when you're
Spark
looking at all the
data,
accumulated data? Yeah, I think they're just trying to, we're not too far into that with this particular customer, but I expect it's going to be just around, more around usage patterns than that. If you think about, a parking facility, they're going to want to know kind of how are things changing in terms of, because they're sensing occupancy, so that can be useful to them just to understand their utilization. The lighting is, in a way, can help them measure utilization in the parking facility. Instead of having a sensor on every spot in the lot, that kind of thing. But we haven't gotten too far into that. And that's something else we've noticed about IoT, just in our projects, is that customers are, early on, are talking about all this stuff they want to do around analytics and their vision for the future, and, you know, it's all good stuff, but the reality is they're still just trying to get the basics kind of going and working and functioning, because, you know, people want alerts when things are down, and they want reports to understand, you know, what's happening, and in a lot of cases in these projects, we're not all that far really into the really awesome analytics that we can do with BigQuery and some of these other tools. So anything else for a wrap up? I think we're just
One quick question. You talked about the message size being about 50 bytes. What are you guys encoding like, data as? The data is integers or like
MQTT doesn't matter, so like the transport of it, it's just bytes. Doesn't matter what it is, right? And so depends on the project. That gateway, they have this highly packed structure, right? They know like these 3 bytes mean this thing.
It's a
the next
binary
byte's-
format.
Yeah, it's a binary format. Just keep things compact. But it could be JSON. It could be anything.
Okay.
But if you're dealing with mobile networks and data is concerned, you're going to want to have something that's very efficient. So, probably not XML. Hey, thanks everyone for coming. I really appreciate it.